In example 3, we want to multiply two binomial expressions. If you're familiar with these types of problems, it might ring a bell that we want to use something called FOIL, where you multiply the first, outside, inside, and last terms together. If you've got that built into your brain somewhere, just go ahead and run with that if you can do that successfully. But what we're going to do is look at a different method, which might make a little more sense if you've had trouble with that FOIL process before, or if you don't understand exactly why we're taking each step that we do in that process. So what we're going to do instead is look at this first binomial, x plus 1, that we have in part A. We need to multiply that by x minus 2. What that means is every term in that first binomial needs to get multiplied by every term in that second binomial. The way we're going to set this up is to just take each piece of that first binomial and multiply it by the second binomial. So we're taking x times x minus 2, and then we'll take plus 1 and multiply that by x minus 2 as well. Now we just need to distribute through and then simplify what's left over. So we'll take x and distribute it through this x minus 2 to get x squared minus 2x, and then we'll take 1 and distribute it through, which doesn't really change anything, to get plus x minus 2, and then we'll look at combining our like terms. In this case, we have minus 2x and plus x, so we'll end up with x squared minus x, or minus 1x, minus 2. If you were to use that FOIL method, if that's one that you're familiar with and you want to apply, great, you'll end up with exactly the same result. But we're going to stick with this other method, where again, we'll look at this first binomial. We're going to start with that first term, minus 4x. We need to make sure it gets multiplied by every term in that second binomial. So we'll take negative 4x times the quantity 3x plus 1. And then we'll take that second term, minus 3, and make sure it also gets multiplied by each term in that second binomial. Now we'll distribute through, and again combine any like terms. This is going to give us negative 12 x squared minus 4x, and then minus 9x minus 3. We'll again look at combining those two middle terms, which are like terms, to get negative 12x squared minus 13x minus 3. In part C, that first binomial is 2x minus 5. So we'll take 2x times the quantity 4x plus 3. Minus 5 times the quantity 4x plus 3, so in each case multiplying by that second binomial. And then we'll distribute through again to get 8x squared plus 6x, and distribute through again to get minus 20x minus 15, which will leave us with 8x squared minus 14x minus 15. In part D, we have minus 5x minus 4 times minus 5x plus 4. So again, one last time, we'll take the first term of that first binomial times the entire second binomial. And then we'll take the second term of that first binomial times the entire second binomial to make sure that each term in the first binomial is multiplied by each term in the second. And this will give us 25x squared minus 20x. Distributing negative 4 through will give us plus 20x minus 16. Now we'll combine those two like terms in the middle, which in this case will cancel out since we have minus 20 and plus 20, and we end up with 25x squared minus 16. Before we move on, we want to stop to note a particular pattern that happened here and will happen with other problems that follow the similar pattern. 25x squared is the same thing as 5x, that quantity squared, and then minus 16 is the same thing as 4 squared, and that happens to be the square of each of the two terms in our two binomials. Or if we were a little bit more specific, this first one is the same thing as negative 5x squared. So it's just an interesting pattern that we can pick up on, and we'll call back on later. Anytime we have something in the form ax plus b times ax minus b, that will always expand out to give us a squared times x squared minus b squared. We don't need to commit that pattern to memory right now, but we will come back and use that again in the future. But it's interesting to note that with this particular pattern, those two middle terms will always cancel out when we expand this out.